Hello, and welcome to Can a Monkey Score a Three-Pointer on LeBron James? I've been asking myself this question for a very long time, and I thought, why don't I just figure it out with math? So here we are. To answer this question, we first need to ask ourselves, how hard can a chimpanzee actually throw a basketball in the form that NBA players use? This is the bone structure of a chimpanzee on the top and a human at the bottom for our shoulders. So, the yellow parts represent clavicles, and as you can see, in the chimpanzee, they are slightly more angled, where in the humans, they are more horizontal. So, these more horizontal clavicles help push out the arm joint and give us a wider range of arm rotation, which allows us to throw at higher speeds than that of a chimpanzee, especially when throwing overhand like they do in basketball. The scapulae, which is represented by these blue parts, also helps throw with more force because they are angled slightly differently than that of a chimpanzee, as you can see here. However, the chimpanzee's dream to become a star basketball player is not 100% a distant memory. A chimpanzee's arm muscles are estimated to be up to 1.5 times more powerful than that of a human's arm, and their swinging strength can be up to 2 to 3 times greater than that of a human's. Now, the pure strength of the chimpanzee's arm almost makes up for the lack of bone structure to support it while throwing, but I'd still estimate that it would be the initial velocity of the chimpanzee's throw would be about 15 meters per second, which is 5 to 10 meters per second less than a professional athlete. So, using this formula, we can find the max height of the ball after the chimpanzee throws it. So, here is the initial velocity. Here is the launch angle in degrees, and here is the acceleration due to gravity. So, plugging in all of our values and assuming the chimpanzee throws it at a 45-degree angle, which is the optimal angle to maximize height and horizontal distance, we get this equation right here. Oh, and 9.81 meters per second is the gravity force. Simplifying this equation, we get that ultimately the maximum height that the ball reaches after the chimpanzee throws it is 3.67 meters. Now, this height isn't completely accurate because it doesn't take into account that the chimpanzee is throwing it from above his head, not from the ground. So, we will need to find how high the chimpanzee can reach. So, to find this, we'll first take its height while standing, which is 1.1 meters on average, and we will find its arm span, which is 1.5 to 1.7 times greater than its total height. So it will be about 1.65 to 1.87 meters. Using this number, we can estimate that one of the chimpanzee's arms is about 0.8 to 0.95 meters. And for the sake of simplicity, I'm just going to use 0.9 meters. Then obviously 1.1 plus 0.9 equals 2. So we can estimate that the height that the chimpanzee is throwing it from will be 2 meters up in the air. Plugging this into our visual, it's clear to see that this chimpanzee is built different, and it absolutely destroys LeBron. But LeBron is in the worst possible position. So, what if he was moved over here? Now things start getting interesting. Oh, also I wrote his height wrong last time. I wrote it as 3.69 meters, but it's actually 3.71 meters, his reach. So, using this script that I only partially made, I used tutorials and a little bit of AI, we can determine that the minimum angle needed for the chimpanzee to clear LeBron but still make it in the basket would be 38 degrees. When it's at LeBron's point, it will be at 3.79 meters high, and when it is at the hoop's point, it will be at 3.67 meters high. So, in the end, the chimpanzee did it. By throwing it at exactly 34 degrees, it can make it at 3.8 meters when it reaches LeBron, who is 0.5 meters away from the hoop. And it can clear him. And then it can make it over the hoop, potentially bounce off the backboard, and make it into the hoop. Therefore, yes, the chimpanzee can score a three-pointer on LeBron James. Thank you for watching. Also, for anyone who wants to use the script, I will put it in the description. It is almost fully customizable. You can customize all the different distances and velocities, and you can even change gravity. But for the one person who actually cares about how it works, I'll explain that. Oh, also, when I was calculating the final measurement, I actually put only 10 meters per second for the initial velocity, which is less than I estimated before, which means that the chimpanzee actually destroys LeBron and has a lot of different ways to do that. Okay, so basically, these constants are the values that it uses on later. Here, this function finds the best angle for a shot that does make it in and goes over LeBron. Here, this tries all angles from 20 degrees to 90 degrees. You can change that as well if you want. It checks each one, and then it finds one that works, and then it converts that to radians so it can calculate this next part. This next part, it calculates the time to reach the hoop horizontally, and then it calculates the vertical position when it's at that point. Then it calculates where the ball height is when it reaches LeBron, using basically the same thing, just with LeBron. The time to reach it, and then the vertical position at the time. Then it recalculates the height it is when it's at the hoop. This is not the most efficient way of doing it, but it does that to check the backboard, to check if it's not over the backboard, because if it's over the backboard, then it could potentially fly over it. Then it checks if all of these things are true, and then if it is, it returns it as an answer. And then the answer is displayed as the angle, the height over LeBron, and then the height at the hoop. All right. Goodbye.